So good morning all. Is my voice clear to you? Just reply somebody.
Yes,
Yes,
sir.
sir.
It's very good. And what about the video?
Sir, it is
About
also
video?
visible.
Yes, sir.
Because see, very shortly we shall actually conduct the experiment. We shall take the reading, and in what way the readings are taken, that must be visible to you also. That's why video will be kept open today. So it should not be like blur. Voice as well as video both should be clear because you have to see the way in which the readings will be taken. Normally, during conventional experimentation last year or many years back, over the years, actually, the students are supposed to take the readings, and this is how the experimentation is to be performed. But today we shall do it virtually, so you must be in a position to observe the way in which readings will be taken by your teachers. Okay, so it should be clear. Let's see what happens today. As you know, the title of the experiment is Cam Jump Phenomena. If you want the exact sequence, then it is, I think, as per our sequence. As per our sequence, the experiment is, let me check, number 4 as per our sequence. I have already posted the sequence in which we have to write the journal accordingly. It is experiment number 4. The title is to verify the cam jump phenomena for an eccentric cam. So usually before actual conducting the practical, before the readings are taken, we have to understand the theory of the experimentation, and then it is meaningful to take the observations. So theory, then observations, recording observations in fact, then conclusion will be the last step. Like we have to prove something. During any experimentation, excuse me, during any of the experimentation, we have to prove something, isn't it? Like in theory of machines one, it might have been the experimentation on finding out the time period, or might be natural frequency, or maybe bipolar or tripolar. It may be anything. Remember that ultimate aim of any experimentation is to determine some of the parameters, come come out with the observations, and then the results and the conclusion. Likewise, today we shall discuss the phenomena which is known as cam jump phenomena. We have discussed different types of cams as well as followers, and we have seen different pairs along with the different motions, like it may be rotary cam with reciprocating follower, or it may be a rotary cam with oscillating follower, and so on. So what we shall do, we shall take one of the case studies, and then we shall try to record the observations and come out with the findings. So remember that the type of cam and follower pair under consideration is eccentric cam with flat-faced follower. We know that eccentric cam is a cam which is actually a circular disc, and the axis of rotation is kept away from center or CG of the cam. Because ultimately what we want is, we want our follower to displace in particular direction. So if you ask me the motion of the follower, the motion of the follower is actually reciprocating or translating follower. So it is basically a rotary cam with translating follower, because ultimately whenever we come across the mechanism of cam and follower, we can ultimately classify the system. So the classification based on motion would be a rotary cam with flat faced follower, and it is going to reciprocate. Okay, eccentric cam with flat faced follower. So rotary cam with translating or reciprocating follower. This is our case today, under observation, of course. Okay, so the title is cam jump phenomena. So we have to actually break down the title, cam jump phenomena, isn't it? So we have to actually understand or discuss the jump, which is the word which is coined. Ultimately, some phenomena is happening in a pair of cam and follower, and that phenomena is described as jump phenomena. So we do understand the meaning of jump. Jump means something which is displaced away from some reference. Likewise, if you jump or if I jump, then ultimately this is actually a phenomenon in which you or I will be away from the ground for fraction of second. This is how I can describe. So if I jump, it does mean that obviously I will be jumping in direction y, isn't it? I will be jumping in direction y, isn't it? So if you want to describe my jump or your jump in simple words, it will be the displacement away from the ground in direction y, in upward direction. Excuse me. No. So jump is all about displacement of some entity, and in that case what will be happening is I will be losing contact with the ground for fraction of second. This is how we can describe the jump, isn't it? So this is supposed to be a jump in direction y, isn't it? So assuming that the jump is short jump, it is not long jump. Huh? Short jump is all about the displacement of some entity in direction y for certain amount of time or fraction of second. This is how, in simple words, I can describe the jump. Coming back to a system of cam and follower, in case of cam and follower, also the follower is going to jump for a fraction of time, and similar to our case, it will be losing contact with the reference surface or with the surface of the cam. So jump of the follower means the displacement of follower away from surface of cam for a fraction of second. So loss of contact of the follower with the driving member, isn't it? Now, why this happens? Is this phenomena really desirable, undesirable? That we shall discuss in due course of time, isn't it? Now, let's assume that this pen is a follower and it has jumped away from the surface of the cam, isn't it? The follower has lost contact due to the jump phenomena from the cam surface. Remember that in real life problems, this is going to happen in a fraction of second. This is just while discussing, I am taking a lot of time, and I'm assuming that right now the follower is away from the cam surface. This is not the reality. In reality, it will be happening in a fraction of second. Okay. Now let's imagine that The follower has jumped away from the surface of the cam and it has lost the contact from the surface of the cam, isn't it? Now, after that phase is over, what I mean to say is that after that jump phenomenon is over, what will happen is the follower will re-establish contact with the surface of the cam, isn't it? Now, while re-establishing contact by the follower, while regaining contact with the cam, what happens is the follower will exert some force onto the cam surface. So, this event is accompanied by generating a particular noise. If you want to sense the timing at which the follower regains contact, then ultimately our ears will notice a particular noise due to impact made by the follower on the surface of the cam. So, when I start the motor, I increase the speed beyond certain limit. Then ultimately, your ears, my ears, will notice at particular point of time particular noise. It's not common noise because ultimately, see, whenever a mechanical system is started, it will generate noise, it will generate vibrations. You can't expect any mechanical system running free of noise, free of vibrations. Even a perfect machine, newly purchased machine, will produce noise, will produce vibrations. I'm not talking about the general noise produced by the machine. I'm not talking about the general vibrations produced by the machine. We are talking about a phase in which, due to re-establishing of the contact by the follower onto the surface of the cam, a particular noise is generated and noticed by our human ears. Then we can say that that corresponds to jump phenomenon. Why it happens? To understand that, we have to carry out dynamic analysis, that is called as cam dynamics. We shall do in a short while from now. But what we are doing is, we want to conclude whether this, whatever happens, is desirable or not. The answer is, it is highly undesirable, because once the contact is lost, beyond that stage, when the follower re-establishes contact, it will produce impact onto the cam. This may cause wear and tear of cam surface, which is not welcome or desirable. Because see, ultimately, we know how to generate profile of the cam. The profile of the cam corresponds to the motion at each and every point, at each and every rotation of the cam. Accordingly, the cam profile is designed. Now, due to this jump phenomena, if wear and tear occurs onto the cam surface, it does mean that, suppose at 40-degree rotation of cam, displacement of the follower was expected as 5 mm as an example, then due to wearing of the surface of the cam, the displacement needed will be away from, will not be 5 mm. It does mean that the other member which is run by the follower will also not get displaced by 5 mm. It may be opening of the valve or closing of the valve, anything. So if the cam profile is not proper, displacement of the follower will not be proper, and that will lead to undesirable displacement of the valve, which is highly undesirable. So jump phenomena is highly undesirable. We have to see whether this is avoidable or this can't be avoided, that we shall discuss later on. Now, let me share my screen because we have to go through the theory part first and then experimentation. Okay. Now, let me share my screen. Where is that? Just wait for a while. Okay. Are you able to see the presentation?
Yes, sir.
So can you read out the first line of the slide?
To verify the cam jump phenomenon.
Okay, very good. I just noticed one thing is that when I conduct lectures from home using laptop, delay time is very short. Very quickly I get a response, but I think when I conduct from our Tom Dum lab, some delay is there. I mean to say that when I conduct the experiment, this delay is going to be there. That may affect our manner in which experimentation will be carried out. Anyway, we shall do it. Okay, means I have to be very slow. I must not be fast while conducting the experiment. So let me enlarge. Shift F5. Next slide. Yes. Are you able to see the picture of the setup?
Yes, sir.
Okay, very good.
Yes, sir.
Yes. Now, don't focus on these two elements, these two setups. The farther one, this is actually called as the setup to verify principle of gyroscope. And this one is actually centrifugal governor. Okay. So next to the cam jump phenomena setup is governor, and next to that is actually your gyroscopic couple. And next to that, you are able to see this control panel that is for epicyclic gear train. So don't focus on these 1, 2, and 3. Focus on one which is closer to you. So the picture is representing actually the experimental setup for verifying cam jump phenomena. Now, whenever I conduct TOM or in particular dynamics of machinery practical, DOM practical, remember that whatever we are doing in our laboratory, that is for verifying the concepts, theoretical concepts that we have learned. If you go to industry, during your employment, and if you look for such experimental setups, these machines like 1, 2, or 3, you will not get to see such machines because these machines are built to support the theoretical concepts. Like the title of the experiment that we are performing today is to verify the cam jump phenomena. But the concepts that we are going to learn or the findings through this experimentation is equally important when you work in industry. So during your employment, please don't try to search for the gyroscopic couple experiment or governor or cam jump phenomena setup. You won't get to see such machines in your industry, but remember that the principle or fundamentals during operation of these machines is to be extracted by you people when you work on real life systems. Just remember that thing, isn't it? The way in which the setup is designed, the forces which are encountered, those will be in industry in all the machines. Only thing is that what we have to do is we have to correlate what we have learned and what is to be applied when you work in industry. That is very, very important. Lesser the gap between our experimentation and the practices followed by industry, more successful will be you people. Conversely, if there is lot of gap between what we are learning and what we are applying, greater the chances of failure. Remember my words. You will recall my statements when you work in industry. Okay? Now, coming back to the experimentation. Whenever you observe the experimental setup, what you have to do is you have to look for the kind of the source of power. So in this case, the source of power is actually a motor. And the motor shaft is coupled to the output shaft. Because ultimately, if you ask me to describe the experimental setup, I will start with the electric motor. The electric motor is coupled to the shaft on which the cam is mounted. So if cam is there, we have to understand the type of cam. If a motor is there, you must look for specifications of the motor, like AC or DC, wattage, RPM, and so on. The cam is mounted on a shaft, so look for the way in which the output shaft is coupled to the motor shaft. Then you are able to see this flange. Inside this flange, we have got a bearing, deep groove ball bearing, which will support the rotation of the output shaft. On this output shaft, an eccentric cam is mounted. So if this is a case of eccentric cam, you must like to know. I'm using word must, not you would like to know. You must be curious about how much is the eccentricity. Because if you are the designer and fabricator of this system, then ultimately you will ensure that there is some eccentricity maintained between the axis of rotation and center of cam. That is for sure. So remember that the eccentricity of this cam is 2 millimeter. How much it is? 2 millimeter. That is going to be same. It will not change for this setup. To change eccentricity, you have to mount some different cam. So you have to make a note of, you have to take a note of parameters which are fixed for that setup, and the parameters, those can be changed. Like one of the parameters that is variable is RPM of this motor, that is variable. So the examiner during oral may ask you like, just make a list of the parameters which are fixed and the parameters which can be varied. So motor RPM is a parameter that can be varied, that we shall do by varying the voltage. Now, we have given enough attention onto the cam and type of cam. The driven member is supposed to be a follower, as you are able to see. This is the follower, long follower, isn't it? So the motion of the follower is reciprocating, and the type of follower is flat faced follower. You have to observe this driven member. If you start observing from the point of contact, then move from down to up. Then you are able to see two nuts, nut 1, nut 2, and now you are able to see a spring like this. This is basically, if it is a spring, then you must like to know the type of spring. The type of spring is a compression spring, helical compression spring. What's meaning of compression spring? Compression spring is a spring which will be loaded during compressed state. The free length of the spring is 106 millimeter. So if it is free of load, the length of the spring will be free length, that is 106. On application of load, it will be in compressed state. So the second parameter that can be varied is length of the spring. It is 106 that can be varied. For that purpose, we are able to see the nuts. This nut, if I tighten, it will compress the spring, and other nut is actually a lock nut. Why to compress the spring? Should it be compressed? That we shall see in due course of time. So, summing up the experimental setup, then we can say that the cam is driven by a motor, and this eccentric cam is going to drive or move the follower, isn't it? Experimentation part, what we shall do? We shall start the motor and slowly change the RPM. Now, at particular speed, in the running condition itself, you get to listen a particular noise that indicates that follower is trying to re-establish contact with the cam. That speed is to be recorded. Means what you have to do today is to be a keen observer and write down the RPM or speed of the motor. That's all, nothing else. You have to record in your notebook the speed at which the noise is heard by you people. That is called as jump speed. Now, what we shall do? Before starting the motor, we shall change length of the spring. It is 106. We shall change it to 104 millimeter. So 106 minus 104 is 2 millimeter. It does mean that you will prepare one observation table. Serial number will be the first column. Second column will be initial deflection of the spring denoted by delta. And the third column will be experimental speed. That's all, nothing else. So initially it will be 104. take the reading of the speed, stop the motor. Further, tighten the nut, change the length of the spring to 102 millimeter, means delta will be 4 millimeter. Tighten the nut, start the motor, change the speed gradually, and at particular speed again you listen that particular noise, that is indication of jump. At that point of time you will record the speed. Observation number 3, it was 104, 102, now you change the free length to 100, so that will be delta equal to 6 millimeter. Again, once you tighten the nut, we have to start the motor, and at 6 millimeter delta you will record the RPM. So this is called as observation table. Okay, now this is the outline of the experimentation, but the core part is to be discussed now, because simply taking reading of delta and RPM is meaningless. We have to arrive at findings based on which we can conclude. To make these observations meaningful, we must understand the theoretical part. Theory is very, very important. Simply taking readings and writing down the conclusion is meaningless if you don't know the theory, isn't it? So, the aim of the experiment is to verify the cam jump phenomena. Yesterday, I have asked you to read out the write-up so that things will be easy for you. I hope all you have gone through the write-up that was given on the group. So in cam and follower system, the follower must be in contact with the cam surface. That the contact is written by means of a retaining spring. So the spring that we are seeing is meant for maintaining contact between follower and cam, isn't it? Because ultimately, remember that when you deform a spring by 2 millimeter, it does mean that corresponding force is there. The spring is associated with spring force. So the spring force is given by K times delta, where K is stiffness, delta is deflection. So higher the deflection, higher will be the spring force exerted by the spring. To explain this, again come back to the arrangement. So if I deflect the spring by 4 millimeter, then ultimately see the manner in which spring applies the force is exactly opposite to the direction of deflection. Remember that you are deflecting the spring in this direction, so the spring will exert the force in downward direction. How much force? That is proportional to deflection. So the spring force will be given by stiffness of the spring multiplied by delta. What is stiffness? Stiffness or springiness is a property of the spring. It will be fixed for that spring. Right now, you are able to see the spring before you. So remember that once the spring is manufactured, its stiffness is going to be constant. It does mean that if the deflection is by 4 millimeter, then the spring force acting downwards will be given by K multiplied by delta. It does mean that K happens to be the system parameter or property of the system. So we know the spring force, isn't it? So the role of the spring is to ensure that there is contact between follower and cam. Now the question is, if the spring is playing a role of maintaining contact between the follower and cam, then where is the question of loss of contact called as jump to occur? And the answer is, if inertia force exceeds the spring force, then ultimately this loss of contact is going to happen or occur. Now, what is inertia force? Inertia force is actually the opposite of accelerating force. Now, let's assume that the follower has moved upward. Let's say that y is deflection of the follower in upward direction. So, acceleration of the follower will also be in upward direction. So, inertia force is opposite to that acceleration. So, it does mean that inertia force will also be acting in downward direction. Spring force will also be acting in downward direction. However, there is also one force offered by a cam onto the follower, that is called as contact force. So remember that contact force offered by cam onto the follower will be acting in upward direction, and inertia force and spring force will be acting in downward direction. Okay, so remember that in equilibrium condition, all the forces must be balanced. Or we can say that summation of all the forces in direction y should be equal to 0, so that there is no unbalanced force. We shall discuss more on this in a short while from now. So, I think this we have discussed, because as is our usual style, we discuss first and then we project the screen. Okay. The condition of jump occurs at high speed and in a highly flexible cam and follower system. So this we have seen. Now just read out this, because you are going to write this in your journal. That I will explain later on, how to write, what to do with the written material, where to upload, that I will discuss later on. Let's finish up the experimentation. During jump, comma is there. During jump, follower lose contact with the cam surface, and when the follower reestablish the contact, it may do so with severe. It's not sir, it's severe, huh? It is doing that with severe impact load that can damage surface of cam, and hammering noise, okay, can be heard at this speed. This we have discussed. With jump, cam and follower separate owing to the excessively unbalanced forces exceeding spring force during period of negative acceleration. The function of cam follower system is to control and constrain follower motion. Okay. Also, life of cam flank surface reduces due to hammering, that is due to wear and tear. It also results into vibrations of system. Yes. The cam jump phenomena can be avoided either by increasing stiffness of the spring, or by limiting speed of cam, or increasing amount of preload of spring. Preload of spring. What is preload of spring? Again, we have to go back to the setup. Now, preload is a load which acts onto the system when the motor is stationary. So to say, right now the motor is not running and length of the spring is 106. So what I will do? I will initially provide compression to the spring, say 2 millimeter. So preload of the spring will be stiffness multiplied by 2. That will be preload. This preload is meant for establishing contact of the follower with cam. In addition to preload, it will be mass of the follower acting in downward direction. So remember that at this point of time, when the motor is not running, it is K delta plus mg acting downwards. So please club K delta with weight of the follower. So just remember in mind that K delta plus mg are going to act downwards. Who has control over delta? People like you and me. Designer is going to control delta or preload. It does mean that during experimentation, delta is to be varied by you and me, so that the spring force is varied, isn't it? The aim is to verify cam jump phenomena, means using mathematics and experimentation, we are going to prove this. To verify means to make use of two methods whose results should match. If the results are going to match by using two different methods, then and then conclusion will be you have verified the principle, or you have verified the cam jump phenomena, or you have understood the jump phenomena. The aim is to make you understand the jump phenomena. Understanding should be backed by the findings. Not that only you will get to listen noise and you have to say, yes, it's understood. Not like that. The understanding of the phenomena should be backed by mathematics, should be backed by findings, backed by mathematics. Okay? Next slide. Let us try to understand the terms which are used in the mathematics behind this jump phenomena. Remember that mathematics is involved in all the dynamic systems. In fact, we can't keep aside mathematics while understanding the dynamic behavior. The system is in dynamic state. Remember that. So why? What is why? Why is the distance covered by follower, or distance traveled by follower, or why is the lift? See, if it is simply a circular disk, then ultimately it will not receive any lift. So why is lift of the follower? That we shall observe during experimentation. M is mass of follower, E is eccentricity, R is radius of circular disk cam, K is stiffness of spring. So Y, M, E, R, K are constant. These are called as system parameters. To change these parameters, what you have to do? You have to design a different cam or different follower. Okay. Next term, delta, is initial compression of spring. That is definitely variable by you and me. Now, the cam is going to exert some force onto the follower so that they remain in contact. So that is called as contact force. F is contact force. It is not phase force. You have to change while writing. Preload of the spring is mg plus k delta. I was talking about this, the self weight of the follower and the k delta term. So these two terms are clubbed and named as P. Preload of the spring means k delta plus mg. So total spring force is P plus ky. Now see, spring is very important component of this setup. Now, when the motor is stationary, we are going to compress the spring. Okay. In the dynamic state, means when the motor is started, then ultimately further spring force will be due to lift which is gained by a follower. Try to understand this. Mg plus k delta is the static term. When we start the motor, then ultimately due to lift gained by the follower, you have additional force that is called as k into y. It does mean that net force applied by the follower will be ky plus k delta plus mg. So keep in mind, three terms which are added, mg plus k delta plus ky. Are you getting my point? Now, RPM can be recorded by tachometer or stroboscope, that we shall do, and corresponding omega will be angular velocity of cam. This inertia force. Now, in physics, we have learned that whenever the body is to be displaced, it must be given some force. Force is equal to mass times acceleration, isn't it? So, acceleration will be caused due to the application of force, or you can say that whenever force is applied, that will cause acceleration. Whose acceleration? It is not acceleration of the cam, it is going to be acceleration of the follower. That is my double dot. Okay. Now, yesterday I have given you the write-up, soft copy. All these terms are there. Now, just focus on the diagram on the right-hand side. I have shown the cam, eccentric cam with the follower. Eccentric cam with the follower. We have to start our discussion from some reference point. And that reference point is stationary state of the follower, that is, motor is not started. That will be the reference point, starting point. Now, in our discussion in last few lectures, what we have assumed is, we have assumed that in our analysis, the cam is stationary and follower is going around the cam in opposite direction. Accordingly, this clockwise rotation is meant for rotation of the cam. It does mean that if we assume cam to be stationary, follower will go around the cam in opposite direction, anti-clockwise direction. Just remember that. Likewise, what we shall do is, we shall focus our attention on two events or two instances. First event will be zero displacement of the follower. So this vertical position is shown for indicating zero displacement of the follower or zero lift. Zero lift. Now, what we have done is, we have assumed rotation of follower through angle theta. Theta is variable. Say 20 degree or 30 degree, any, even 10 degrees also okay. So theta is variable. What is theta? Rotation of the cam. For analysis, rotation of the follower. Remember that when theta is zero, when lift is zero, then the contact force between cam and follower is highest. Are you getting my point? Now, at that instant, the lift of the follower is absolutely zero, because motor is not started. When the motor is started, then slowly cam will start its rotation, and as the rotation of the cam proceeds, remember that this is eccentric cam, then profile of the cam will drive follower. That is called as lift of the follower. Accordingly, at some instant like this, we can assume that follower has gained some lift. How much lift? Again, mathematics comes into picture. We have to derive the equation for the lift of the follower with respect to theta. Remember that the lift of the follower expression contains rotation of the cam, that is theta term. Additionally, it will also contain E term, that is eccentricity. What is eccentricity? It is distance between center of cam, I mean to say center of cam Q, and axis of rotation. Remember that this is a point of axis of rotation. You can imagine a shaft perpendicular to the screen. That is the location of the motor. Okay, so you can imagine that axis of the motor shaft at this point, and this is center of cam. To find out the lift, what we shall do? We shall take OS2, difference of OS2 and OS1. Remember that at this point, the point on the cam is in contact with the follower, I mean to say cam, and now OS2. So OS2 minus OS1 will be giving you the lift. Refer this. Lift of the follower, instantaneous lift of the follower is Y equal to OS2 minus OS1. OS2 minus OS1. What is OS2? OS2 can be regarded as YA2. YA2. You do know meaning of trace point. What is trace point? Trace point is a point at which the motion gets transformed. So remember that at this instant, the trace point and contact point are coincident. Due to rotation of the cam, separation of contact and trace point occurs. Remember that A2 is next position of A1, S2 is next position of S1. Now, due to rotation of the cam, A and S are going to separate. Accordingly, you have this contact point, you have this trace point. Since we know that trace point gives you idea about the transformation of motion, so you have OS2 minus OS1. Accordingly, it is written like this. What is OS1? Remember that this much is radius of the cam R and this much is eccentricity. So OS1 is capital R minus E inside this bracket. What is OS2? So OS2 that needs some construction. So what is done is, this is a line which is drawn perpendicular to this, and through this contact point one more line is there. So OS2 is equal to YA2. YA2 can be written as QA2, which is radius of cam, plus QY. Accordingly, A2Q, this is A2Q plus QY. QY is to be found. Okay. Now remember that this is theta and this angle is 180 minus theta. I'm getting this from this triangle. This angle is 180 minus theta. This side is small e. So QY will be cos term. It will be E cos of 180 minus theta. I repeat, cos of 180 minus theta is QY divided by E. So QY will be E into cos of 180 minus theta. So E into cos of 180 minus theta is minus E cos of theta. I repeat, E into cos of 180 minus theta is minus E cos of theta. Accordingly, focus on this. You have Y equal to this plus that minus this. So this is R, this is minus E cos of theta, and this is minus R minus E. So you get R minus E cos of theta minus R plus E. Finally, lift of the follower driven by eccentric cam is given by E inside the bracket 1 minus cos of theta. That you have to remember. This is lift of the follower or displacement of the follower. Its velocity will be E omega sine of theta, because E into 1 is 0, minus cos will become sine. So E into sine theta, further d theta by dt. So it will be E omega sine theta velocity. Acceleration will be again differentiation of this. You will get omega square E cos of theta. So this is very important. I hope you understood, or else you may go through the write-up once again. Next slide. This is heart of the experimentation. Force analysis, dynamics of cam. This is the actual system, and this is actually free body diagram. Now, the system is under the action of 1, 2, 3 forces. I hope you understand the spring force exerted in this case. So it is downward spring force, downward inertia force, which is My double dot, and upward contact force exerted by cam on follower. Please take screenshot of this slide because this is not in your, so to say, the write-up. You have to take screenshot of this because this is asked by the examiners, because this is the most important part. It is downward spring force, downward inertia force, upward contact force. So what we have is, this is actually F. F is equal to My2 dot plus Fs. Now as the follower is displaced in upward direction, the acceleration of the follower is in upward direction, means inertia force to be in downward direction, spring force in downward direction, and the force exerted by cam on the follower, however, will be in upward direction. So next, now actually this is not needed. This is actually a part of dynamics of machinery. I will skip it. I will explain to you during dynamics of machinery. So with that, we have F equal to My2 dot plus Fs. F equal to My2 dot plus Fs. We have discussed it is P plus Ky. P plus Ky. What is P? You have to go backwards. P is called as preload, which is Mg plus K delta. So let's quickly go through that. F equal to My2 dot plus, what is P? Mg plus K delta plus Ky. So finally you have F equal to My double dot plus Mg plus K delta plus Ky. F is equal to P as it is, but P is, remember, Mg plus K delta plus K as it is. Y. What is Y? Lift of the follower. It is given by E into 1 minus cos of theta. How we have derived? Plus mass of the follower into Y. Y2 dot. What is equation of Y2 dot? Yes, it is known to you. E omega square cos of theta. So you have F equal to P as it is, Mg plus K delta plus K into bracket plus M into bracket. You have F equal to P plus Ke, K into E plus, now these terms are simplified now. You have to work on equation number 4. All similar terms are clubbed together. You have minus Ke cos of theta. This is minus now. Minus Ke cos of theta and M omega square cos of theta. So cos of theta is common. In fact, E is common. K into E cos of theta with negative sign, and this is cos of theta. So you have, for the second and third term, you have E cos of theta multiplied by M omega square minus K. This is mathematics. What next? As already said, when the motor is stationary, the contact force is highest. That corresponds to lowermost position of the follower. Remember, theta equal to 0, lift is 0. It does mean that follower is in lowermost position. Remember, at that stage, contact force is maximum, means you can put theta equal to 0. Now, at the same time, it will be least or minimum when theta is 180 degree. Because you can find out magnitude of cos of 180. Are you getting my point? Cos of 180. Due to this cos of 180, due to this 180 degree rotation of cam, the follower will lose contact. This is very important. Accordingly, put cos of theta as cos of 180. At that point, loss of contact means this will be 0. Remember that this is contact force. What I am saying, at 180-degree rotation, cos of 180 will be minus, means loss of contact. So this force will be 0. So 0 equal to P plus A plus E cos of 180, and the same thing it is written here. So finally what you will get is ME omega square. Now this omega is written as omega j. When theta is 180, omega will be omega j. What is omega? Angular velocity of the cam. So ME omega square equal to P plus twice K. What we have to do? We have to observe the loss of contact. So who will indicate loss of contact? The particular hammering noise. That noise corresponds to some speed. So experimentally, we shall sense with our ears the hammering noise and record the speed of the motor. Experimentally, this is done. Theoretically, you shall find out the omega, that is speed. So expression for jump speed, this is called a jump speed equal to square root of P plus twice K divided by M into E. So what is omega? 2 pi by 60. So RPM will be equal to 60 upon 2 pi square root of P plus twice K upon ME. But remember that, focus on this final equation. K is constant, E is constant, M is constant. P is equal to mg plus k delta. Mg is constant, only delta is variable. So theoretically what we shall do, we know K. I will let you know that. K is known, E is known, M is known. P is mg plus k delta. Mg is also known. K is constant. So we shall put different values of delta as 2, 4, 6. We shall find out the theoretical speed first. And we shall perform the experiment. We shall check for delta equal to 2, whether theoretical and experimental matching or what. And then we can conclude based on that. So the setup consists of an eccentric cam and follower with a follower spring whose motion at any time, what is written, I don't know, contact speed becomes 0. Okay. The specification of the setup. It contains a DC motor, half HP, 230 volt. Spring stiffness is 892 Newton per meter. Free length is 106 millimeter. Mass of the follower 0.354 kg. Cam dimensions OD, ID, eccentricity is 2. Procedure is given to you already. These are the observations. Of course, of the previous year. This year, those will be different. Remember, first two columns will remain same. Theoretically, you will calculate today itself. Experimentally, we shall record. Sample calculation first. Now see, one announcement is there. Tomorrow at 11 a.m. HOD sir will be talking to you. That is very important session. That is all about academic activities, your submission, evaluation to some extent, and examination norms and all that. So you have to remain present tomorrow without fail. Okay. Accordingly, you have received our message from Bhumkar sir on the WhatsApp group. So at 11 a.m. sharp, all must be present. That is very, very mandatory. Okay. So let's focus on sample calculation and then we shall start experimentation. As I said, it's sample calculation for delta equal to 2 millimeter. So for delta equal to 2 millimeter, P equal to mg plus k delta. This is fixed mg and k is fixed and delta is 2 millimeter. That is 2 meters you have to take. Units should be consistent. So P is found as 5.256 and theoretical speed is 60 upon 2 pi. P is known 5.26 plus twice K Stiffness is 892, E is 0.002, M is known, mass of the follower 0.354. In this way, theoretical speed you will get as 1066.04 RPM. Similarly, you have to compute the same thing, theoretical speed for 4 millimeter, 6 millimeter. This you will write in your notebook, and then experimentation is to be done. Okay, so that you can do at your own end. Now give me 1 minute. I will make some adjustment, and I will place my laptop near the screen. Okay. This one. Okay. I will stop sharing my screen. Back to Google Meet. I have to switch on my video now. And now I have to display physically along with my mobile. Just give me a second. Now please reply, are you able to see the setup properly? Because I am not able to see. Shubham and Himanshu, are you present? Or anybody, Joglekar, Surnis? Are you able to see my mobile?
Yes, sir.
Mobile,
Yes,
you are
sir.
able to see now. Can you see my mobile?
No, sir.
Are you able to see my mobile? Speak loudly.
No, sir.
No, sir.
Now,
No, sir.
now,
Yes,
Yes,
sir.
sir.
because see,
Yes,
I
sir.
have to ensure that you see base and top. So can you see the mobile?
Mm,
Yes or no?
no, sir.
Now,
No.
no. Now, are you able to see?
Yes, sir.
Okay. Now, are you able to see mobile?
Yes, sir.
Yes,
Yes, sir.
sir.
And you are able to see the two pillars, two columns?
Yes,
Yes,
sir.
sir.
Very good. What we shall do now? We shall measure length of the spring, and it will be 106, no doubt. We shall compress the spring by 2 millimeter, isn't it? Then we shall start the motor and observe what happens to the noise. Okay, so please be attentive. Okay. Is video clear or blur is there?
It is somewhat blurry, sir.
That is going to happen. See, with the help of the scale, the length of the spring is adjusted to 104 millimeter because it is 106 initial. Now it is 104 means deflection by 2 millimeter. Upper nut is taking care of compression, and the lower lock nut will ensure locking of upper nut. Once it is done, then the lower nut is locked. That is called as lock nut. With the help of spanners, Shinteser is helping for conducting the experiment. He is common Doppler in charge. And now stroboscope is there. With the help of stroboscope, the speed will be recorded, and additionally, you will be able to observe the jump phenomena. That is very interesting. I will drop today's video in your WhatsApp group. Later you can see as a reference. Now the speed is being increased. Now I will be silent so that you can listen that hammering sound. This is general sound. Now, are you able to notice change in quality of sound? This is the speed which is to be recorded because this corresponds to loss of contact. This is called a jump speed. The follower is trying to contact the cam. While doing so, impact load is being applied onto the cam. So we shall record with the stroboscope. You might be knowing principle of stroboscope. When the frequency of flashing light matches with the RPM, the object will be appearing as stationary. Now the cam is appeared as stationary. So please record this observation. The speed is 1288. At 2 millimeter, speed is 1288 RPM. Okay. Now what we shall do? We shall stop the motor, and again deflection will be adjusted to 4 millimeter. So I will write in on group 2 millimeter. That has given us 1288 RPM. So that it will be referred later on. 4 millimeter, we shall enter the RPM. 6 millimeter, and then did you see the stationary cam? Are you able to listen to me? I'm asking you, When the lights were
Yes, sir.
flashed by the
Yes, sir.
stroboscope, did you notice that stationary cam?
Actually, it was not very clear.
Okay, means it was out of vision of the camera or it was blurry. What you mean to say?
लॅग होते लॅग
काय होता?
लॅग लॅग मोबाईल म्हणजे
Lag, but it was kept there for some definite point of time. So let's see. Now 4 millimeter. So for 4 millimeter, RPM is 1300. RPM is 1300, and there is correction for 2 millimeter. It was 1188. I repeat, for 2 millimeter it was 1188 RPM. For 4 it is 1300. The final reading 6 millimeter. Shambhat, 100. Now it is 100 millimeter as fill length, means deflection is by 6 millimeter. This will be the final reading. But don't leave at the end of the final reading. We have to discuss more on this. Now, this is the hammering noise, uncommon. So please note down, it is 1419. Well, thank you. So I have posted the readings on your group. So to summarize, for 2 millimeter, it is 1188. For 4 millimeter, 1300. For 6, it is 1419 RPM. Chala, thank you. Yeah. Just wait. नंतर 5 मिनिट. So how was the experience? Virtual practicals for the first time with this. So what we have to do now, using the write-up, we have to find out the theoretical speed. Theoretical speed at which jump occurs, and you have to compare the theoretical speed and experimental speed. So slight variation will be there, because ultimately while modeling the system, not that we consider all the parameters, and the real system, I mean to say, the success of the result always depends on how well you have taken all the parameters in your mathematical calculations. So slight variation will be there, but I hope these are reasonable speeds based on my experience. For 2 millimeter AA, theoretically slight change will be there, change of mismatch of 50 or 100 RPM, that is accepted. Okay. So in case of any doubts, please revert back. You may drop the message on the personal group. Let's wait for the link. But once again, remember that you have to attend all the practicals for theory, here and there, few lectures, absence. Okay, but for experiments, you must be present for all the lectures. I mean to say all the practicals, that is very, very important. And we don't know whether repeat session is possible in the virtual mode. That's why I urge you to be present for the practicals. In the next session, we shall perform the experiment on rack shift. The write-up is also given to you. Just 2 minutes, if you can spare. Addition to this, remember that you have to write the theory, experiments, you have to draw the diagram, and you have to write the conclusion and all that. Write-up is must. So I will ask you to write the first, I mean to say this experiment, cam jump phenomena, using journal pages. From title to conclusion, you have to write. Diagrams you may use as it is, like I have given you the scanned copy. So as it is, you may use the diagrams. No need to draw the diagrams. It is concession given to you in the virtual mode. But you have to write the experiment the moment you have completed. Today we have done this, so you have to write the experiment. Very shortly, I will ask you to scan the write-up and upload at certain platform, but you have to be ready. Remember, you have to scan the write-up, individual write-up, and you have to either email or upload on the drive. That I'll let you know later on. I hope things are clear to you.
हॅलो सर.
Yes, Vibhav Jagtap, yes.
तर ते 2 mm 4 mm आणि 6 mm कशाची लेंथ आहे ते नाही कळालं मला.
Okay, it is length of the spring. See, 2 millimeter is the deflection, compression given to the spring. Initial length of the spring is 106 millimeter. Initially, we compress the spring by 2 millimeter. Delta is the compression in the spring. Delta is the difference of free length and compressed length. So 106, 104 deflection is 2 millimeter. Next deflection reading is 4 millimeter. For 4 millimeter deflection, the length of the spring will be 102 millimeter. And the third reading is deflection of 6 millimeter, means the compression given to the spring is 6 millimeter. Is this okay, Vaibhav?
Okay sir, thank you.
Any other doubt? But once again I repeat two things. You must be present for all the practicals. That is the mandatory requirement. You should not be in trouble later on, because no repeat experiments will be conducted. No excuse for that. Number two, you must you have to write, because everything is given to you. The write-up is given to you, the readings are given to you, observations are given to you. You must write. Thirdly, you have to upload your write-up. You have to scan the write-up and upload whenever I ask you. Within 2 days, I will ask you to upload or email to me. That must be done. And the last thing is that tomorrow HOD sir will be engaging lecture at 11 AM for discussing academic activities, your schedule for term work, practical, and your submission, how it will be done and all that. So you must be present for tomorrow's lecture. So let me drop the attendance link in the group and fill in the response, and please do the needful. I will wait for 5 minutes and then I will conclude the meeting. Thank you very much.
Excuse me, sir.
Yes, yes, yes. Now, yes.
Sir, for MQC and HT, we are getting printed write-ups that we only write observations and do the calculations. So can we do the same here also?
No,
It
no,
will
no.
save time.
No, no, no. You have to write it down. For diagrams, I have given you the concession. Diagrams you may use as it is, but you have to write. There is specific reason behind writing down each and everything, because that is as good as you study something. When you write means you are studying that thing. That's why not ready-made journals. You have to write. Diagrams can be referred as it is. That is compulsory. Writing down the journal.